Let's recap and summarize what we have learned. Route filtering in routers is the process of controlling which routes are allowed into or out of a routing table. It is a critical aspect of network management used to optimize routing, enhance security, and control traffic flow. Below are the summary key points about route filtering. Number one is the purpose of route filtering. What we can achieve by route filtering. So the benefits are limit unnecessary routes. So prevent unwanted routes from being propagating, reducing router overhead. Control traffic flow. Direct traffic by selectively permitting or denying certain routes. And enhance security by blocking potentially malicious and unintended routes from entering the network. So that's basically the purpose of route filtering, and it's very important in today's time where ransomware and all these malicious IP addresses and sites are everywhere. Now let's discuss the mechanism for route filtering. Since we are mainly talking about Cisco routers, and all other brand of routers, I think will support the same type of methodology when it comes to route filtering. Cisco routers support several tools and methods for filtering routes. ACLs. ACLs are used to permit or deny specific prefixes applied in routing protocols to control which routes are accepted or advertised. The second option is prefix list, more flexible and efficient than ACL for route filtering, used to filter routes based on prefix and prefix length, as you have seen in my lab. Route maps allow for more flexible filtering by matching conditions and applying actions. Can be used to modify attributes like metrics or set specific conditions. Distributed lists apply ACLs or prefix lists to control routes in the routing protocol updates. Can be used inbound or outbound in routing protocols like OSPF, EIGRP, BGP. And finally, policy-based filtering, particularly used in BGP with route maps and policies to influence route decision. When it comes to BGP, BGP is a distance vector protocol, so you have to basically filter routes based on direction, and that will be covered in the BGP course if you're interested. Now, application of route filtering, how do we apply it? We can apply it inbound filtering and outbound filtering. Inbound filtering, of course, controls which routes are learned from a neighbor or peer. Outbound filtering is, of course, controls which routes are advertised to neighbors or peers. So, as a network engineer, you are responsible for both inbound and outbound filtering. And this is part of the controls document that you should have if you are managing an organization with large networks or even small networks these days. It's important to know what's coming into the network and what's leaving out of the network. Now, the best practices, use prefix list over ACLs for filtering IP prefixes due to better performance. We have seen that in my lab. Combined route maps with distributed lists or prefix lists for advanced filtering. Regularly review and update filters to align with network changes. And be cautious with route filtering in dynamic protocols to avoid creating black holes or suboptimal paths. That's important with dynamic protocols because they use multicast, and you need to make sure, you're not filtering the multicast hello and dead messages in the dynamic protocols. So that will come maybe with practice and learning more about dynamic routing protocols. Protocol specific considerations, BGP. With BGP, you will use extensive use of route maps, AS filtering, AS path filtering, and community filtering for policy enforcements. I have a colleague of mine who's just managing BGP in one of the companies, and that's a job of its own, managing BGP filters, managing BGP traffic. So you know the extent of knowledge of having BGP is so important. When it comes to OSPF and EIGRP, you will need to use distributed list and route maps to filter routes and be mindful of specific protocol constraints. By employing route maps filtering effectively, network administrators can maintain efficient, secure, and predictable routing behavior in networks. I hope that's clear. And with this, we have concluded our course in route filtering. Some of the best examples I have provided are in the labs. Please do them on your own if you are practicing. It's a good way to learn different ways of filtering route maps based on our discussion here. And I wish you best of luck, and do subscribe and look for more courses that I've been teaching in networking. Thank you again, and see you again.